On September 16th, Apple released the new iPhone 14, coming in two different models, the iPhone 14 Pro Max and the iPhone 14 Pro. With the new models came new features unique to the iPhone 14, like a new dynamic island at the top, upgraded cameras, car crash detection and satellite connectivity for emergencies, the A16 Bionic chip for faster performance, and new deep purple and space black color options. However, they have minor differences in height and battery life. But fundamentally, they both have the features unique to an iPhone 14, so it doesn't really matter that they have a difference in size or battery life or whatever. They will still be iPhone 14s. My name is Joy Song, and I will be introducing isotopes. First, I'll go over the vocabulary and the concept, and then I will give you some examples and true or false review to test your knowledge. To put it simply, isotopes are atoms with the same number of protons and different number of neutrons, or just different versions of a certain type of atom. We'll be going deeper into this later, but to understand this, I'll quickly just define some terms. An atom is a particle of matter that uniquely defines an element. Some examples are hydrogen or oxygen. When many atoms bond together, they form a molecule. Protons, neutrons, and electrons are all a little similar based on the fact that they are all subatomic particles that belong to atoms. However, electrons can either be bound to an atom or float around, while protons and neutrons belong in an atom's nucleus. The difference between the two is that protons are positively charged while neutrons are uncharged. Now, you've already learned the definition of an isotope, but let's take a closer look at what an isotope really is. Here are three different atoms: oxygen 16, oxygen 17, and oxygen 18. As you can see, all three of these have the same number of protons and electrons because in an oxygen atom, the number of protons and electrons are equal. The 8 protons and electrons are what make the oxygen atom an oxygen atom, like how the dynamic island at the top of an iPhone 14 makes it an iPhone 14. However, in oxygen 16 there are 8 neutrons, but in oxygen 17 there are 9 neutrons and 10 neutrons in oxygen 18. This makes these atoms isotopes of oxygen because they all have the same number of protons, but a different number of neutrons. The number next to the word oxygen in each of these atoms is called the mass number, and it's the sum of the number of the neutrons and protons in each atom. And so the mass number for oxygen is 17. And so the mass number for oxygen 17 is 17, because oxygen 17 has 8 protons and 9 neutrons. 8 plus 9 equals 17. So now you have a brief understanding of isotopes, but how does my previous analogy of the iPhone 14 models connect? Well, both the Pro and the Pro Max are the iPhone 14, just like in the two isotopes, they are the same element. But they both have their own features, like a smaller screen or a longer battery life, which sets them apart. Alright, now let's look at some other examples of real isotopes, like the isotopes of carbon. Take a look at these atoms. What do you notice? Well, all of these atoms have the same number of protons, 6, which makes all three atoms carbon atoms. So these are carbon isotopes, carbon 12, 13, and 14. As you can see, if you add up the neutrons and protons in the isotopes, you get the mass number. Let's look at another one. Now here are some hydrogen atoms, hence the 1 proton. Since there are fewer protons and neutrons, it'll be easier to add up the mass number. Try doing it yourself. Clearly, there is 1 proton in the first one, 1 proton and 1 neutron in the second one, and 1 proton and 2 neutrons in the third one. But the number of neutrons doesn't change the fact that there is 1 proton in each atom, making each atom a hydrogen atom. Now let's figure out how to write an isotope notation. This is a brief idea of what isotope notation looks like. The M, like I have said before, is the mass number. This is the sum of the protons and neutrons and varies from isotope to isotope. Z is the number of protons. In isotopes, the number of protons are the same. As I said earlier, this is what makes the atom individual. For a neutral atom, the number of protons and electrons are equal. So the reason why the mass numbers for isotopes are different is because of the number of neutrons. They are different. And finally, the X is for the symbol of the element. For example, O for oxygen or C for carbon. Okay, this is how you write isotopes in atomic notation. Write an atomic symbol for an oxygen atom with 8 protons and 7 neutrons. First of all, we know that this is an oxygen atom, so let's write an O in the place of X. Okay, so oxygen has 8 protons and 8 electrons, so the number 8 will replace Z. A reminder that the Z is the number of protons in the isotope, so we're going to add the 8 on the bottom left. And finally, we need to replace our M, which is the mass number. And the mass number is the sum of the protons and neutrons. The problem says that we have 8 protons, which we already wrote down, and 7 neutrons. 8 plus 7 is 15. So the last number we have to add to our atomic notation is 15. So this is our atomic notation. Let's try another one. Write an atomic symbol for a carbon atom with 6 protons and a mass number of 14. So in this problem, we have the element, mass number, and number of protons provided. Let's start with the element, which is carbon. We'll put a C in the place of X. Okay, now the next piece of information provided is the number of protons. In carbon, there are 6 protons and 6 electrons. 6 will replace Z and take its place at the bottom left. And finally, the mass number is given to us already, which is 14, which will replace M. Okay, let's do one more. Write an atomic symbol for a chlorine atom with 20 neutrons and a mass number of 37. Alright, let's start with the first piece of information, the element. The element here is chlorine, whose symbol is Cl, so we can write that down. Cl replaces X. Now, in this question, we are given the mass number, which we know is 37, and the number of neutrons, which is 20. However, we still need to find the number of protons that will replace C. Now, remember that the number of protons plus the number of neutrons is the mass number. Since we know the mass number and the number of neutrons, we can use simple algebra to solve for the number of protons. We can form an equation that follows something like this. Z, the number of protons, plus 20, the number of electrons, is 37, the mass number. Then we simply take away 20 from both sides and end up with Z equals 17. And this is our final product. Now let's review with some true or false questions. Take a moment to try to solve these on your own. Alright, you should have gotten true, true, false, false. Number 1 and 2 are true because they describe the definition of an isotope. Atoms with the same number of protons but different numbers of neutrons, or just different versions of a certain type of atom. But numbers 3 and 4 are false. In number 3, it states that isotopes can be the same type of element or different elements. This isn't true because isotopes need to be the same kind of element, even though they have a different number of neutrons. And number 4 is wrong because the mass number isn't the sum of the protons and electrons, but the sum of protons and neutrons in an atom. How'd you do? So that was a brief summary on isotopes. Thanks for listening.